Somewhere in the mountains of Papua New Guinea, the jungle does not give back what it takes. Vines grow through cockpit windows. Roots split aluminum skin panels along rivet lines. Moisture works into every joint, every seam, every place where two pieces of metal meet. The process is slow, and it is total, and it does not stop. But it is not always fast enough. In 1944, a B-24 Liberator heavy bomber disappeared over the Owen Stanley Range during a mission over Japanese-held territory. It did not return to its base, no distress signal was received, no crash report was filed by any ground observer. The aircraft and its 10-man crew simply vanished into the mountains, the way dozens of aircraft vanished in that year, completely without explanation, without coordinates. For 52 years, the jungle kept it. What a survey team found in 1996 was not wreckage scattered across a hillside. It was not a burned crater. It was an aircraft. Broken on impact, yes. Structurally compromised in several sections, yes. But recognizable, coherent. Sitting in a remote highland valley at an altitude where the temperature stays cool enough and the drainage is good enough, the deterioration had proceeded at a fraction of the speed it would have at lower elevations. The crew did not survive, but the machine they flew outlasted half a century of jungle by sheer accident of geography. This is the story of how it got there, how it was found, and what it looked like when the world finally saw it again.
The B-24 Liberator was the most produced American combat aircraft of World War II. More than 19,000 were built. It flew in every theater. It carried more bomb load farther than the B-17. It was also, by the accounts of nearly every crew who flew it, a more difficult and less forgiving machine. The Davis wing, the high aspect ratio design that gave the B-24 its range, was efficient in cruise and unforgiving in damage. Where a B-17 could absorb considerable structural punishment and remain flyable, a B-24 with serious wing damage had a much narrower margin. The fuel system, with tanks distributed through the wing and bomb bay area, was vulnerable to fire in ways that gave the aircraft a reputation among crews that the official performance numbers did not capture. In the Southwest Pacific Theater, these characteristics intersected with a geography that was uniquely hostile to aviation survival. The Owen Stanley Range, running spine-like across the center of Papua New Guinea, reaches altitudes above 13,000 feet. Weather over the mountains was violent and unpredictable. Turbulence, icing, and rapidly building thunderstorms could transform a routine transit into a survival.
An aircraft that impacts terrain at controlled or partially controlled speed in mountainous jungle does not behave like an aircraft that impacts at cruise speed in flat, open country. The distinction matters enormously for what survives. A high-speed impact in flat terrain typically results in total structural destruction. The kinetic energy has nowhere to go except into the airframe itself. What remains is fragmented, scattered, and rarely recognizable as an aircraft, except by the distribution of debris. A terrain impact in steep jungle highland, where the aircraft may have been descending under some control, where the slope angle can absorb and redirect energy, where trees provide sequential deceleration over hundreds of feet before the final ground contact, produces a different result. Sections of the airframe absorb specific impact loads and fail at specific points. Other sections, protected by the geometry of the impact and the energy already dissipated, may remain largely intact. This is what the survey team found in 1996. The B-24 had come down on a slope in a highland valley at approximately 7,000 feet elevation. The impact sequence was reconstructible from the debris pattern. The outer wing panels had separated first, absorbing enormous energy as they contacted trees and the slope surface. The forward fuselage had compacted significantly. The bomb bay area showed the characteristic destruction pattern of fuel-fed post-impact fire, contained, burned out, but not extending to the rear fuselage or tail section. The rear fuselage was intact. The tail assembly, horizontal stabilizers, vertical fin, rudder, elevators, was standing. The turret installations were present. The control surfaces still showed the original olive drab and neutral gray paint scheme under the biological growth that had colonized every surface. 52 years of jungle growth had covered the aircraft so completely that it was invisible from the air. Ground visibility was limited to a few meters in every direction by the density of the vegetation. The survey team found it not by visual search, but by following a combination of local oral history, wartime missing aircraft records cross-referenced with approximate course lines.
The condition of the aircraft when found was a direct product of its elevation. At 7,000 feet in the Papua New Guinea highlands, the environment is fundamentally different from the coastal lowland jungle that most people imagine when they think of the Pacific Theater. Temperatures are cool, sometimes cold at night. The fungal and insect activity that destroys organic material in lowland jungle at extraordinary speed is significantly reduced. The bacterial decomposition processes that break down aluminum oxide layers and accelerate corrosion are slower. The result was that aluminum structure that would have been unrecognizable after 50 years at sea level was still structurally coherent at altitude. Not undamaged. The impact had done its work, and the half-century of moisture cycling had done its work, but coherent, recognizable. In sections that had remained dry, the metal retained structural integrity that surprised the survey team's engineers. The paint, in sheltered areas under wing panels and inside the fuselage where direct precipitation had not reached, retained color. Not bright, faded, chalked, partially obscured by biological growth, but present. The original markings were recoverable under careful cleaning. The instrumentation in the cockpit area was destroyed by the impact compaction of the forward fuselage, but in the rear section, equipment had survived. Oxygen system components, electrical junction boxes, ammunition in the turret installations, still live after 5 decades, requiring careful handling during documentation. The aircraft was a time capsule. Not a pristine one, not a comfortable one given what it represented about the fate of the crew, but a time capsule nonetheless.
The physical condition of the B-24 allowed investigators to reconstruct aspects of its final flight that no document could have provided. The engine condition was particularly informative. All 4 Pratt & Whitney R1830 engines remained with the aircraft, 2 still partially attached to the wing carry-through structure. Examination of the engine internals revealed that at least 2 engines had been running at reduced power at impact. The pattern of internal component wear and the position of throttle linkages were consistent with an aircraft managing a partial power emergency rather than complete engine failure. This suggested the crew had not experienced a sudden catastrophic failure. They had been managing a situation, probably for some time before impact. The aircraft had been flown into the mountains under some degree of control, which was consistent with the impact pattern showing a controlled descent angle rather than a stall or spin entry. The fuel system told another part of the story. Tank selector positions preserved in the wreckage showed the crew had been managing fuel transfer, another indicator of active crew response to an emergency rather than sudden incapacitation. The aircraft had not simply fallen out of the sky. It had been flown by its crew until the terrain took it. That distinction, readable in the physical evidence of the wreckage, was the closest thing to a final account of what those 10 men experienced that any investigator would ever have.
The decision regarding the Liberator was made relatively quickly once the survey team reported their findings. The aircraft would not be recovered. The combination of terrain, remoteness, structural condition, and the logistics cost of recovery from a highland location accessible only on foot made physical recovery essentially impossible without a budget and organizational commitment that was not available. What was available was documentation. A second expedition, larger and better equipped than the initial survey, reached the site in 1997. The team spent 3 weeks on site conducting the most thorough field documentation possible, given the conditions. Photographic survey was conducted systematically. Every section of the aircraft, every structural detail, every surviving marking. Dimensional measurements were recorded for every major component. Structural assessments were made to determine which sections were stable and which were at risk of accelerating deterioration. Paint samples were collected from sheltered areas for laboratory analysis. Metal samples were taken from corrosion-affected and non-affected areas to characterize the deterioration chemistry. Soil samples were collected from beneath the aircraft, where decades of fluid drainage had created a chemical record of the fuel and oil systems. The documentation archive that resulted was, in the judgment of the aviation archaeology specialists who reviewed it, one of the most complete field records ever made of a Pacific Theater B-24 loss site. The aircraft remained where it was. It remains there today. The jungle continues its work, but the record of what it looked like in 1997, 53 years after it came down, exists in permanent form. That record is the recovery, not physical, but informational. The aircraft gave up its story, even if it could not give up its structure.
The Liberator in the highlands of Papua New Guinea is not unique in category. Across the Pacific Theater, across the mountains of Europe, across the deserts of North Africa, aircraft from World War II continue to exist in states that range from scattered fragments to remarkable preservation. What determines survival is not importance. It is not the fame of the crew or the significance of the mission. It is geography, temperature, drainage, the specific chemistry of the local soil, the altitude that slows biological processes, the slope angle that determined how energy distributed through the structure on impact, variables that had nothing to do with the human decisions that put the aircraft in the sky on that day. The B-24 Liberator was the most produced American combat aircraft of the war, more than 19,000 built. Of those, a fraction survive in any form. A fraction of that fraction survive in conditions that allow meaningful study. And of those, almost none combine the completeness, the preservation quality, and the documentation record of the aircraft in the Papua New Guinea highlands. It survived by accident of geography. It was found by the intersection of patient research and systematic search. It was documented by people who understood that physical recovery was impossible, but informational recovery was not. The jungle still has it, but the story is out.